So first tell us the problem, then you'll start the working principle. Okay.
Yeah, the problem is to send a file from the client program to the server via reliable method, but using UDP. My part is
Yeah.
on UDP. So, and we also have to make sure that if the transfer breaks somewhere in between the transfer, so that the next time it will resume from up to that point it has been transferred. Okay, so the resume actually happens. That is the um, problem. So, sir, may I start now? Hello, sir.
Yes, yes. Please continue.
Okay, sir. So my working principle for the client is first we create a socket and connect to the server. Then we read the file and then determine the total number of packets to be sent. And then we'll first in that in we'll have three types of frames. That is a calibration frame, a data frame, and one for terminate connection frame. Okay. So in the first frame, that is the calibration frame, we will send the file name, the total amount of data that will be sent per packet, and the total amount of data in the first calibration frames. All these will be sent in the calibration frame, and after that, we will send the data per frame, the actual data. And in the client side, whenever we receive an acknowledgement, then we will check that if it is the correct acknowledgement that we are expecting, then we will send the next frame. But if it is not the correct acknowledgement, then we will resend the same frame. And after the total send transfer is complete, we will send a connection termination packet at the end. For the server side, we first create a socket and bind to the socket. Now, if when at the server side, when I receive a packet from the client, if it is the first frame, that is the 0th frame I'm considering, that will be the calibration frame, then I will initialize all those data that has been came through that frame on the server side. That is the total file size, the file name. I will initialize all these variables, and then from the other consecutive frames, I will collect the data and put it into the file on the server side. And whenever I receive a request to terminate connection, then I'll just terminate connection and the program will close. Uh, and now if the server on the server side, if the packet that I am receiving, if it is the expected packet that I was expecting on the server side, then I will keep it and send the acknowledgement for the next packet. But if it is not, then I will again send the same acknowledgement that has been sent last. And after the whole transfer is complete, I will copy the file. The file is been written completely, and then the server will exit. So now this is my frame structure. The first variable is a frame type variable that will be of three types, and that is the sequence frame or the data frame, and then terminate connection frame and calibration frame. Now there will be sequence number, the frame sequence number, then acknowledgement number. This will be used for the server side when server will be sending us the acknowledgement. This buffer size will be the how many bytes we will be sending per frame, how many data bytes. And this data array will be containing the actual data bytes, and this file name will contain the file name. This will be used in the first calibration frame, and this is the total. This will be the total file size, and this total frames by total size will be 1472 bytes. Considering all this, okay. Now this is a flowchart explanation of the how this is transferred. On the client side, we create a socket, we connect to the server, and we read the file, then create the frames. And now from while creating the frames, I will get also the total number of frames to be sent based on the file size and how many bytes I'm sending per packet. Based on that, we will have a frame count that will be greater than 0, and we will continue until all these frame counts hits 0. So I will continue until all the frames has been sent. So uh, if the frame count is greater than 0, then we know that the transfer hasn't been completed. So we'll go here and check if it is the first frame. If it is the first frame, we will send all the information, the file information and all this through this frame and send to the server. But if it is not the first frame, then we'll know it is the data packets. We'll send the data packets to the server. And after sending one frame, if we know that it is the correct frame, our acknowledgement is all right, the correct acknowledgement we have received, then we'll decrease the frame count by 1 and continue until this hits 0, and when it hits 0, we'll exit. On the server side, we first create a socket, the connection, we establish the connection, and we receive frame. And from the calibration frame, we will know how many frames to be received here. So if until all the frames has been received, we will be going here, and the very first time we will check if it is the first frame, then we will initialize all those variables from the frame information. Uh, and then again continue to get the next frame. And if it is the last frame, if we know that all the frames has been received, then we'll write the file. The file write will be completed, and then we'll exit. And when we are receiving the frame, if it is not the first frame, if it is the data frames, then we'll write the datas and then put it in the file. Now this is the headers we have used, total headers, and this data per packet is a variable that we have defined as 12 bytes. That will be, this many bytes will be sent per frame in our case. These are some functions we have used to read from the file. This fseek is used to get the file pointer to a specific position in the file stream. This fread is used to read from the file a certain amount of bytes and store it into the message. Now, how many bytes will be written will depend on this size, and this is the size of the how many bytes will be written, and this is the how many times it will be read. So if I have this as 1 and if I have this as 256, then we'll be reading 1 byte 256 times. That will be total 256 bytes will be written, and this is the file pointer from where to read. Now, this seek end and seek set are two variables that actually denotes where to put the file pointer. For this is used in the fseek function. Seek end will put to the last index of the file stream, and seek set will put to the first index of the file stream. And ftail is used to get the current index of the file pointer. Now, fwrite is used to write something to a file. The something is the contents of this message buffer into the file pointed by fl, and this is same as that fread, that is this number of bytes will be written and that this many times it will be written. So if 256 bytes to be written, then I will have that as 1, and this will be as 256 as before. And file open is used to open a file, and that is denoted by this file name. That will be the path of the file. And mode is there are multiple types of modes. That is read and read binary modes, write binary modes. This mode specifies in which mode to open the file. Now, this is one important segment that is used to actually read the file from the correct index indices, because when we again start for the retransfer, then our file's index needs to be corrected to the right position up to where the file has been transferred. Otherwise, it will be erroneous. So this will be I am having as first a bytes left will be, this is on the client side. Bytes left will be file length minus frame number minus 1 into buffer size. This buffer size is how many bytes I am sending per frame. From this frame number, I know up to which frame I have already sent, how many frames I have already sent. So that minus 1 into buffer size will give me how many bytes I have already sent. And file length is the total number of bytes. So from this equation, we are getting how many bytes left to be sent. Now, in the next line with fseek, I'm first setting the file pointer to the last index, and then I'm coming back for those many bytes that is left to be sent. So this negative bytes left is used as an offset to come back. So as negative, so it will go to the left direction. And now in the last line here, this buffer size and bytes left are compared with each other. This buffer size is fixed at 1212 and bytes left will gradually decrease as more bytes are being sent. And now, so for all the five first bytes except the last one, the buffer size that is 1212 will be greater than bytes left, because for the last byte, for the last frame, the amount of bytes to be sent will be less than less than the 1212 number, because that much bytes may not be completely available to be read. So when that happens, I mean, this function is used to read the correct values. I will explain it later. Let's just go to the example. Suppose here I have 7 bytes. So in the first frame, my buffer size is 2. So I will read, in each frame, I will send 2 bytes. At the very first, say bytes left is 7, and number of frames will be 4. That is just the data frames. This is not considering the calibration frame or the terminal connection frame at the end. So number of data frames will be 4. So because 1, 2, 3, and the last frame will only have 1 byte, but still the frame number of frames will be 4. So at the first data frame that I'm considering as slice 0, that will be sent here. That will be sent. So in the first time, the frame send dot data will be this. So by buffer size is less than bytes left. So this part will be executed, because as it is a ternary condition. So this part will be executed. That is, I'll be sending buffer size amount of data. That is 2 bytes I'll be sending. So this way it will continue for these 3. So in the second time it will be also be the same. Now the third frame I haven't shown it, but I'm showing it for the last frame. Now for this frame, uh, the bytes left is actually less than buffer size. So this condition will be false. So this part will be executed. That is, I will be sending just the bytes left amount data, not the whole buffer size. That way, for the frame, this will be the actual file, and this part will be some garbage folder that I will not consider on the server side as well. Now, on the server side, this is again the same function. Just for the server side, I'm written the bytes left will be at the very beginning initialized from the calibration frame. That will be the file length, because at the very first, the total file length is left to be transferred. Now each time I receive 1 and I decrease the bytes left by how many bytes I am receiving. That is, I'm considering that I will always receive 12 bytes. That's why, yeah, because this is, I'm making it reliable. So I'll always receive the 12 bytes in each frame. So bytes left is decreased by that much. And they say this is the same thing. For the first frame, this will be transferred in the first frame, so that will be put to the output file. Then this will be the transferred. Then this will be transferred. I'm just not showing that. And in the last frame, the garbage part is excluded using this for a line, this ternary condition. Because in the last line, again, the bytes left will be less than buffer size, so this part will be executed. And then that way, just the file is copied, not any garbage. And now my source code starts from here. I'm just having 3 variables. That is the file length, the buffer size will be how many bytes I'll be sending per packet, and this temporary array. Now this is my frame. My frame is having 1 variable for the frame kind, denoting which frame it is, and then the sequence number, then acknowledgement, and then the buffer size, that is how many data per packets. That then a array for the actual data containing the data, the file name array, and the total file size in bytes. Now this is for creating the socket on the client side. This is the regular normal thing. I'm not explaining this. And now here I am reading from I'm having a file name array for storing the file name, that file that I will be reading. Now I'm reading a file from here. Now after that, I'm opening the file in read binary mode, because if we open it in any other mode, it will not be transferred properly. Now I'm going to the end of the file with secant, and with ftail I'm getting that the position of the file pointer, that will be my file length, total file length. And then with fc coming back to the beginning of the file, and I'm just printing the total file size that I have read. Now this is for calculating those statistics, not statistics, the frame number and all the how many frames I will be having. So yeah, this is the temp variable. I'm just storing the file name divided by buffer size, and with that, I'm just frame count will be the seal of that, because this temp variable will be a fraction, and for the fraction part, I will also be needing a whole frame. So I'm taking the seal, and this one is for the very beginning, the calibration frame. That is the then I will get the frame count, and this frame count original is used later just for that I'm storing it here as well. Now at the very first, I'm declaring my frame number to be 0. That will be the 0th frame, which will be the calibration frame. Then 2 frames, that is for sending and for receiving. Now acknowledgement count, this is for just calculating some statistics at the end. And then how many bytes done, this is also the same thing. And this is the timeouts for how many times the server has timed, the client has timed out, and this terminate timeout is used to actually know when to exit the program. That is, if it has timed out too much, then this client will exit. This bytes left is the same variable that I've described before. How many bytes that will be left after sending each frame. Now this is from where the main program starts. I will continue until all the frames has been sent, that is until my frame count is 0. Now if for one frame sending, if it is the first frame, that is the calibration frame, I will send my calibration frame type to 2, frame kind to 2, because that denotes the calibration frame. Sequence number will be frame number, which is 0. Frame number is initialized as 0. Then size in bytes, that will be my total file length, and buffer size is this buffer size contains the how many bytes will be sent per packet, that 12 bytes. And then I'm copying the file name into the frames variable for the file name. It's a string copy, and then just sending the frame. If it is the for calibration frame, I'm doing these things. Now if it is any other frames, that will be the data frames. I will set my frame kind to 0, as it will be data frame. Frame number will be frame number, whatever it is. This frame number will be incremented after each iteration of this loop. And this is the portion that I have explained before, to actually copy the correct part of the file into the data of the frame data array, and then I will be sending the frame. And after on that many bytes is done, I'll be incrementing these bytes with that. And now then I'm waiting for 15 milliseconds to 50 millisecond timer is client waiting. If it fails, I mean if it doesn't receive any acknowledgements, after that it will be sent. So I'm waiting 15 milliseconds, and then I'm checking if I have received anything. Now from receive from, I'm having this as a message don't wait. That means for the client, for this function, the client will not be blocked. It will just check if it has received any data, and if it hasn't, then whatever it is just it will continue. Now if it has received some data, that is from the server, then this acknowledgement receive will be the frame receive.sek will be correct, or if it hasn't received any data, then this will be some garbage value. That is, this condition will not will be true. So, and if it receives some frame something from the server, then this will be true. Then it will say that it has received acknowledgement, and I will increment how many acknowledgement I have received that, and this terminate timeout will be 0. I will explain this line a little bit later. And this frame count will be decremented by 1. But now if this condition is not true, that is the client hasn't received a proper acknowledgement, then it will consider that a timeout has occurred, no acknowledgement received or any wrong acknowledgement received, whatever, it will consider the timeout has occurred, and then this bytes turn will be decremented, because before I am considering here that when I'm sending a data frame, I'm considering this bytes has been sent properly, but here I'm finding out that it has not been sent properly. So the bytes turn will need to be decremented. A timeout will be counted, a timeout will be incremented, and this terminate timeout will also be incremented. This timeout is for knowing how many times the client has timed out overall the whole transfer. And this terminate timeout is used to know, that is, if the terminate timeout hits greater than 500, then the client will know that it has received too many timeouts, and it will consider it as a connection lost. Now
There'll
this
be
2 minute,
network, but
yes,
in terminate town timeout is greater than 500 means if you use the greater than 50, then also it will work because that
yes,
means your network will be down. Yes.
yes, sir, yes, sir.
Hmm.
And this value here, this terminate timeout equals to 0 is used because suppose it is receiving a lot of timeouts, and this terminate timeouts goes up to suppose for if I'm considering 500, it goes up to 300 or 400. But after that I'm receiving a valid acknowledgement, then I know that my connection has not been terminated. My connection is still there, it was just taking too long, but it is still there. So this terminate timeout will again be resetted to 0 in this here. So it will again, yeah, start from 0 count, yeah, checking here. That this way it will work. And here this frame number will be set to whatever acknowledgement I have received. That will be the next frame that I will be sending. And this percentage done is just some calculation to find out how much I have transferred already. That's it. Now this is where the while loop ends. So my whole transfer part of the code is just these 3 slides. This while starts here on if condition, the else part, and out of that if else, this portion, and while ends. Now with that, the transfer will be completed. Now here I'll be closing the file that I was reading from, and this is for calculating how much packet loss has occurred overall, and how many timeouts have I have encountered. Then with that, I'll be writing those two in a log file, and then I'll be closing the log file here. And after all these are completed, I'll send just an termination request frame to the server, so the server can exit as well. And with that, the client program stops here. Now for the server program, this is the frame that will it is the same thing, the frame structure. This is
Same, the file, the structure is same, the both the side, client and server.
yes,
Yes.
sir, yes, sir, same thing.
Hmm. Hmm.
Then this is the socket creation for the server, that is socket creation. Then the address will be put here, the address initialization, and then the binding. And that's, I'm not explaining this now. From here, the server side main thing starts. I'm initializing 2 variables. This will be just used for some loop later. Then there are 2 frames, frame send and frame receive. And then this is the file length, a variable for storing the file length that I'll be receiving from the client. Buffer size for these things are for the same things. The buffer size will store the how many data bytes I'll be sending per frames, and this bytes left will be for knowing how much bytes is still left to be received. And this expected frame number is initialized as 0. That is the whatever frame the server was expecting, for knowing that, and a character array for file name for storing the file name. Now I'm opening 2 files here. One is the output file, and another one will be a log file for logging how many frames I have sent or I have received already. That way the server will send the correct acknowledgement back to the client. And the very start, I'm just expecting that I will always receive the 0th frame first, so my first acknowledgement will start from 1. So I'm just having it declared here. Now I'm opening the first time opening for, I'm searching for a file named the resume transfer log, and if this file doesn't exist, that means that means which file that I'll be receiving it for the first time. So I will open a new log for that file and then continue. So, and if this log file exists, then that means I am receiving some file that that has already been transferred partially. Now, so if the log file exists, I'm just writing a log file is found. Uh, just a second. Yeah, this is will be the my log file structure. So in my log file, the first line will be the file name. The second line will be how many data per package or the buffer size, uh, and then it will contain 0 every time for the 0th frame. Yeah, that is, I'll be storing the frame numbers and bytes left afterward, but for the first 0th frame it will store 0, and then for the other, the last two lines, these two lines will be repeated for each frame, and this will contain first the frame number and the bytes left after receiving this frame, and these two will be continued, yeah, even continued in the log file repeatedly. So now when I'm reading from the log file, this is the structure. So at the first time with the app gets, I'm getting the file name. So the first line is read here. I'm getting the file name, and from that file name, as this app gets has a new line character attached to it, whatever it reads. So from the this file name, I'm just removing that new line character to get just the file name part, and then I'm having this temp buffer says this is a character array. So with fgets, I'm then getting the buffer size, but this needs to be converted to int, but it will read as a character. So that is why I'm first storing it into the temp buffer size, and then from that I'll be putting it into the buffer size variable by converting from ASCII to int. Now I know the file name of the file that will be continued, and so with that file name, I open the file. This file will already be present in the server side, and I will open it in append binary mode, because something has been already written to it, and I will write to it after up to the part it has already been written. From that I will write to it. I'm just here printing the file name here. Now this part, yes, this part is used to get the last two lines from the from the log file. These last two lines, this will be repeated, and the last of these two lines I will get from the log file using this part. So I'm using while f gets, I'm just reading all those lines and I'm storing them. First I'm storing one line to this last line variable. These three line, last line and last to last line are just three character arrays, and I'll be putting from the fgets, I'll be reading into the line, and with the line I'm storing them into these two other variables. So after this whole thing is done, this last line will contain the very last line of the file. That will be the how much bytes has been left, because this line will contain how much bytes left, and last to last line will have this line, which will be the frame number up to which I have received from the client. Now with those two, this last frame will be, yes, convert the last to last line will contain the last frame, but that will be as a character, so we need to convert it into integer using that. And the acknowledgement will be whatever the last frame I have received, that plus one. Extracted frame number will also be the same, and bytes left will be again from the last line, whatever I have read, that from that character to integer, I will convert it and put it into bytes left, and then I'll close the file. This log file, I will close it and then again open it in append mode. Because after I have read the log file, I will again need to write to it for the next frames that I will be receiving. So I'm closing the file here and opening it into append mode, because before I have opened it into read mode here. Okay, now the server side code starts here. The server this while will always run. Now server will first using this receive, it will receive a packet from the client, and it is blocking because this message wall is used, so it will block until something is received from the client. Now if now whatever frame it releases, it will first check the frame kind to know if it is a calibration frame or a data frame, and it will also check if it is the correct frame that it was expecting or not. And now if it is the calibration frame, it will initialize those variables on the server side. That is, from the frame, I will get the file length, how much bytes left will be the total file length, because it is the calibration frame here. Then buffer size, I will get it from the frame. That is how much data I will be receiving in per frame data bytes. And with the string copy, I'm copying the file name into the uh, file name from the frame into the file name variable on the server side. And then I will open the file. This file is the actual file that I will be transferring from client to server, and I'll be opening this file using write binary mode, because this is the first time. So this is the calibration frame, so I'm assuming that I haven't received any file with this file name before. So for the, because we are having this for as a first time, so I'm opening it in read binary mode. Then in the log file, I'll first put the file name, then the buffer size and the sequence number for the calibration frame part, and I'll have my acknowledgement to be the frame number, the sequence number I have received, that +1. Now, if it is not the first frame, that is, it is a data frame, so my frame count will be 0 here. Frame sequence number, I will check that to know if it is that frame that I was expecting. And then these two lines that I have explained before to copy to the correct portion of the correct part of the file, so the index that matches while copying to the file. And whatever I am receiving here, whatever frame I am receiving this to, that frame number and how much bytes left after receiving that frame will be written to the log file. And then again, the acknowledgement will be updated accordingly. That's it. Now, if it is not those two type of frames, that is a terminate connection frame, then I will just terminate the connection, and this is a break here to break out of the while loop. That is, my program will finish. And now if it is none of this, that is, whatever I have received is not something valid, that is, this expected frame number doesn't match in any of this, so I know I'm receiving some wrong frames. So I am just using this else. I am decrementing this expected frame number here, because after this if else part, I'm always incrementing this expected frame number too. So to compensate for that, I'm just decrementing it here once. Here, this is where the expected frame number is incremented always. So if it is not the valid frame, then this will be incremented. So to compensate for that, I'm decrementing it here. And now after all of these are done, this send to is for sending the acknowledgement packet back to the client. And with that, the while loop ends here. Now I will just close the log file and the input file that I was transferring, and the log file I will close here, and after that the server will close. So that's it.
No, if suppose when you are resuming, na, maybe after some time something will be happen. So that part you should discuss. Okay.
Okay. Yeah. Yes. Sir. Right. Yeah. Now, when I'm resuming, so this here.
You are sending files, but somehow your server or client side is closed. Then what will
Yes,
be
sir.
happen? Uh, After some
Yes, sir. Yes,
times.
sir. I'm explaining, sir.
Okay.
So as I now let's consider it again. Suppose this if condition is true. I'm considering if it is when it is the first time first. So a new file will be open, and this entire section will not be executed. So my because before that this was there, so my expected frame number will be 0. Okay, so this part will not be executed. So in here it will come here, and this part will be executed. But if I am having a log file there in the server side, then it will come to this here, and here you can see this expected frame number gets updated to this value, not 0. So after that, after having this, so whenever I will receive a 0th packet, that is a packet with frames sequence number as 0, but this condition won't match, so this will not be calculated. Okay, so after the none of this will be calculated, so mm, this frame
Means
number will.
when you are sending the segments, so
Yes
in the
sir.
receiver side from the log file, it can easily identify that I am receiving the wrong segments.
Yes
Okay,
sir.
so
Mm,
from the log record, it can easily identify. Okay, so I already received some packet of these files, so I
mm,
have to restart from some points. Okay, so that
mm.
point should discuss. Hmm.
Yes sir. Yeah. um Now if I have received the I am having a log file, then this thing will be executed. And here you can see this acknowledgement. The next acknowledgement that will be sent to the client is updated to the frame that I have received last, and received last plus one. So, and this line, this acknowledgement will never get updated in any of the other places of this while loop. So all of these conditions will fail, but in this send to line, this acknowledgement is still the last frame plus one. So the suppose I have received up to 300 frames, so acknowledgement 301 will be sent here, and in the client side, client will always send the packet for which it has received the acknowledgement. So if client receives acknowledgement 301, then it will send a frame number with frame number 301. So in the next time the mm, client the server receives the frame, it will receive a frame count of 0, this sequence number will be 301, and this expected frame number will also be 301, because this was also updated here, this expected frame number, and that way the transfer will begin again. Then it will be just continuous, and it will be incremented by 1 every time, and the whole transfer will be done. Yes sir, that is all I think I can explain.
So is there please explain, please execute the code. Hmm.
Yeah, yes sir, yes. Mm,
And also show that if
mhm.
in
The
between
trans yeah,
if network
breaks.
is
Yes
down,
sir.
then you have to resume from the where you have closed the
Yes
connections. Okay,
yes sir.
একটু পারলে enlarge করো একটু বড় করো।
হ্যাঁ হ্যাঁ স্যার, সেখানে এটা একটুখানি ইয়ে করে নিই। Okay, so yeah, and this is the server side, compiling the ATS and client side. Yeah, so the client asks for a file name, and the server starts here. So as there was no log file there, the server first created the log file, and it will put the corresponding file name that it will receive here. Sending this 3.docx file.
send some image file বাবা
Okay, okay, sorry. So just one thing, I'm sending that.
okay okay হুম, হুম।
I'm sorry, here you can see I was sending the docx file, and I'm stopping the client abruptly. So the transfer has broken here. So if I open this file, it will give me an error. The word is here not correct, and you can see these pictures are not visible. So can you see that? Hello?
Yes, yes, yes.
So I'm not saving the file. So I will again transfer the same file. The transfer begins again, and I will let it finish. And now as it has finished, so the server has stopped. I will open the file, and now it doesn't gives any error, and the file, the pictures that was previously broken, now it has completely transferred. So it's all openable now. So now I'm sending the image file. Okay. So one thing I want to say, sir, you told me that I should
Hmm.
make it so that multiple files can be transferred even when
Hmm.
this log is there. So actually I
Hmm.
have done that, but I haven't updated the PPT. So
Okay, no problem.
I'm
So your log file name should be the file name before.
yes, I
Uh,
have done that, but if I want to say that if you want me to show it, I can show it right now, but my PPT is not updated to that. Okay.
okay, no problem. So only send the image file. Okay.
Okay. So for that, I need to delete these two files or this code. Okay. Now here, starting the server here, and I'll be sending. So wait a second, I'll get a bigger file here. This image, and that is called 5.jpg. Okay, so the transfer is going on. This percentage done is showing. I'll stop it around 10%. Okay. I'm stopping it here. You see the file is being transferred only a little. Now I will continue the transfer. It starts from there. It's going on, so it will take a little bit time. If I open the file here, okay, it can't open right now.
Okay, please wait. Only
Mm,
50% byte.
yes, sir.
50% of the file is sent, na? So
Yes, sir. Okay, now it's done, and it is transferred completely.
excellent. So any doubt from the students? Any students? If anybody have any doubt, okay. So please close your presentation.
Okay, sir.
So Dibran is ready. Dibran is here.
Thank you, sir.
Ah,
Yes,
Dibran.
sir. Yes, sir.
Okay.
Will I
Please,
start?
please start your presentation.
Yes.
Some parts are almost same, na? The file operations and all the things. Dibnaran?
Yes, sir. I'm starting.
No, no. What I'm telling you that some
Yes.
parts are common. So file
Yes,
operation.
sir.
Mhm. So you can skip. You can read, but you can skip that part also, huh, if possible.
Uh, okay, sir. So is it visible?
Yes, yes. Presentation mode. Yes, please start.
Okay, so this is the assignment 3, flow control implementation, stop and wait using the TCP and UDP protocol. So what is the problem statement is we need to transfer any type of file from one node to another node where we are mentioning that is a client and server. We are sending any type of file on the implementation of stop and wait under TCP and UDP protocol. So the problem statement says that the protocol will send any type of file. Each packet should consist of the file name, sequence number, acknowledgement, and other some details. And for the client or server, there will be a log file generated to resume the transmission because it is a stop and wait protocol. So what are the problems addressed here? That the program can transfer any type of file. A log file will be also generated, and we have implemented the manual retransmission for broken connection under the TCP protocol. So the question first will come that why again TCP in stop and wait? Because we know already that TCP stops for the response from the server or wherever it sends first the data. So the main thing is when TCP sends them some data, it waits in default for a response from the another node. But actually, in the stop and wait, we have to also retransmit the data if it is the connection is broken. So this is the new thing in the stop and wait. That's why we have to implement the stop and wait in another way in TCP, because TCP is a part of stop and wait. So there are some prerequisites we need to know to totally understand this protocol, how implemented in the TCP. So there are three main challenges. First one is the file read and write, TCP socket communication, and the stop and wait implementation, that how we have implemented this one. So here is the C language. So from different languages, it will syntactically some change, maybe changes. So let's first discuss about the file read and write. So here we have to know the binary file read and write. We actually, if you use the read mode, just R, then it will be the file will be open in just read mode. But here we need to use read binary mode, that is RB. So my cursor is visible. So here's a read binary mode. So what will happen if we don't use this read binary or write binary, that is WB? So suppose this is a file contains the body part and a header part. So if we open the file using R, only with R, then the program will just read the content of the body, not the header data. So it will just read the content of the body, and when it will write, wherever it will write, if you write in the client side or in the server side, it will just write the body part. So here you can see this header part is not this one because it is written that default header. Because actually the program when opens with the read mode, it seems like when it will write, it will just append the text header part. Because suppose here it is a MP3 file, so MP3 header will be different from a text header. So when we open the MP3 file in the read mode and we are writing also in the write mode, it writes the body part, it's fine. But it's append the text header part here. So when we are appending a text header, then later on when we'll open the file, the program will understand that it is a text file, not a MP3 file. So we have to also read the header part. So to read the header part, to read the whole content of the file, we have to use the read binary and write binary mode. So this is the main thing we need to know to reading the file here. Because we have to send any type of file in this communication. So these are some file read and write functions already discussed, that fopen, fseek, ftell, fclose. And just I'm telling that here we are opening the fopen.
Divyan, please repeat 1 second, no problem.
Say here?
No, the next thing, please tell us 1 second.
Yes, so file equals to file open, fopen, file name, and RB. So here we are opening in the read binary mode. So the whole content of the file will be read. So there is another concept is raw file. Suppose we are reading the data using R. Okay, we are reading the data using R mode. So the body content will be loaded in the program. And we are writing in WB mode, write binary mode. So what will happen there? That when we are opening or reading the file in read binary or write binary mode, means the whole content is read. So when we write in write binary mode, the program in default will not add this header part. So it will just write the body part. So that time it becomes a raw file. Here it is an MP3 file, here it is a text file, but that time it will be a raw file because we read the body part and we just write the body part. And the header part was not appended there because we have used write binary mode. So that will be a raw file. So here we have read the data. We already read the data in the read binary mode. Here we have specified the file name. It will be a string type data. Fopen is a function and it is a pointer, the function. F6. So F6, we need to specify the pointer. Here you have specified the pointer file 0 and secant. So what is a secant? Secant means we are specifying that from where to start. Where to start the means the reference. And 0, this 0 is the how many bytes we need to go from anywhere. Like suppose it is 100 or it is a minus 100. So what will happen? If it is 100, then from the secant, it will go next 100 bytes. And if it is a minus 100, then before secant, it will go in the left side minus 100 bytes. So secant means at the end of the file. If it is 6 set, I will also tell later that if it is 6 set, that it will define the beginning of the file. So the next function is the ftail. So long size we have defined because the file size can be in gigabytes. So that's why we have specified that it will return a long. The file size is a long type data. And ftail, we need to specify the file pointer. So ftail will return the offset part. Means actually here when we run the fsig, the file pointer where it is pointing, it will go to the end of the file. Now, when we'll call this ftail, it will say that where is the pointer right now. So that means if it is in the end of the file, when it will say the end byte, means suppose it is 100 bytes of data, then if for this function call, the pointer will go to the 99 byte. So it will return that 99 or 100 position. So we'll assign that to the f size, that is the file size, and finally f close. And there are two another functions, that is the fread and fwrite. So there are 4 types of parameter we need to pass. First one is the actually from fread we are actually reading the file. So after reading, where we will store. So first part is actually the storing variable. So where you need to store the container. So here we have actually specified a array. Temp is an array name. J is the where is the index of the array, and ampersand is to specify the location, the reference. Now size of char, it is specify the number of elements we are reading. Sorry, the number of the data byte actually we are reading. So size of char means 1 byte we are reading. How many 1 bytes we are reading? 1 means one time one function call. One time one function call we are reading just 1 byte of data. And from where we are reading? This is the file pointer from this file. So here we have opened this file, and here we are reading 1 byte of data using this function. So 1 byte of data will be stored in this array, in this location. So suppose we have mentioned that it is a char array, character array, and it is supposedly 10 bytes of array. So each location is actually 1 byte. So we are reading this 1 byte and storing this 1 byte here in this location. J, we are specifying the location by J. And this is a write. So here tinfo is another structure in the variable. We are also specifying the location by the ampersand. And we are specifying that how many bytes we are writing using this function. So we don't know about that how many bytes are already written to this. So we are using the size info size of t info. So here we are specifying what have to write. Here we are specifying how much byte we have to write, how many elements we are writing, just one because it is one variable, and what is the pointer. So you can see that there are 2 different pointers is there because this is the 2 different files are there. It is a variable, and this is the actually we are reading from a file. So next one is the sample code snippet. So here you can see we have first defined a file pointer. Then we are opening a file. So a file name is actually a variable. Then we are go to the end of the file using the secant, and we are actually taking the position of the file where the pointer is now. So we will get the file size using the ftail, and we are again setting the pointer to the beginning of the file, because when we will read, we are not start from the end of the file, because whenever we will try to read from there, it will show a end of file. So we have to go to the first position of the file. So we need to use this 6 set. Here you can also specify the bytes, how many bytes you need to do the offset. Here also you can specify this one. So next prerequisite is the TCP socket communication. So there will be 2 things, that from one is in the client side and another is the server side. So client side will connect to the server, and the server side first tells the client side. So we are actually creating the socket in the localhost address or the loopback address. It's told 127.0.0.1. It can be different thing also. like your IP address, which was assigned by your router. So by using this address, you can run your program in a same machine. And so first we are getting the host name, then we are actually initialize the socket. If the socket is not initialized, then there will be an error. So it will be printed here. So socket is initialized. After that, we are assigning the family, address family. We are assigning the port. We are assigning the address also, what is the address, and we are filling all with zeros, all the addresses. Now we are beginning the connection to the server. So here the connection, here we are giving the socket descriptors, and finally other details like server address and the size of data. So if the connection is established, then it will be printed that it will go after this function, or else it will print the connect error, and it will exit from the function. And this one is the server TCP side. So it will also create a socket. If it is an error, then it will print here. It will also assign the ports that where the server will run. This one is the client one. This port is for the client, and this port is the for server. So that will be different. That can be different also. Then we are actually here. We are connecting the desk to the server. We are mentioning all the ports where we need to connect. But here we are creating the binding the port, means we are actually uh, blocking the port, so no one can use that port for any listening part. So we are binding first. If it is unable to bind, that means already some server or something it's running on that port, so it cannot be binded. After that, it is listening. So already if the binded, then it will listen. So listen means we need to first, in the first parameter is the sock, that is the socket descriptor. And the next parameter is actually how many connections we will listen in the queue. So suppose here we have mentioned that 5. That means if at the same moment 5 requests comes from anywhere to the server, it will set to the queue. If more than 5 requests is there, then it will be connection timed out from the client side. Like we see that there is a network connection, we can't connect to the server. So that's why once we have, there is no connection can be made at this point, because this is the max number of clients at one time can to a request to the client. So after that, if it is also there is no problem, then the TCP connection means it is listening for the connection from client. So here we have mentioned the 5000 port. That's why here it will be printed here. Next, so we know now the binary file read write and the TCP communication. Now the part is stop and wait implementation. What is the different thing here? So in the stop and wait implementation, actually the main different thing is we need to retransmit the data if the connection is broken. So to retransmit the data, we have to also know that how much it is transmitted already. So for that, we need to maintain a log file. So here you can see, just I will also explain it later, but here you can see that we are reading the file in this for loop, but 1 byte at a time. Here you can see I already told that size of char we have mentioned that it will read the 1 byte, and number of how many byte will read, that is 1. So 1 byte at a time. So here the for loop will run that many times. How what is the size of the file? Suppose there is 1000 bytes of file, that means 1000 times this loop will run, because we need to read that 1 byte at a time. So this loop will run 1000 times. Now, suppose we are sending one byte by byte. Okay, that's 1 byte sent, 2 byte sent, 3rd byte sent. At any moment, the server or the client can close. So what we are doing here, that whenever we are sending any byte, we are opening the log file and we are writing the log file. So suppose the 10th byte it's fault. That means already we have written that the 9th byte already sent to the server. So it should be written at every time. We are opening and closing. Suppose this FP, this line, FP equals to OF open, and this line is before this for loop, and we are closing after this for loop. So what is the problem? In that case, we have opened this here. We are writing this here, no problem. But suppose the client stopped when it is reading the file. So what happened? It didn't close the file. That means the data, whatever we have written, it will not be saved. So we all need to open the file, and we also have to close the file at the same time whenever we are sending. Means I want to say that before this f read, you can't open, and after this f read you can't close. After f read or the before f read, you need to open and close at the same instance. So it will be there will be no problem. So this is the client side, and same like the same way in the server side will be there. So in the server side, what will be happening here? The client actually maintain the log file, and client sends that I will send after this type of data. So offset part we are sending that much of byte I have already sent. So I will send from this byte. 1,000 bytes I have already sent the 200 bytes. So 200 will be sent to this server. So the rest will be initialized here. The A to I, this function, what it does that whenever we are using the socket, whatever it is sending, it is type of string, or you can say the 1 byte of data in array. So when it will be type of string, we need to at least convert. Here we are assigning to the segment number that how much byte I have received. So it should not be a string; it should be integer. So to convert the string to the integer, we need to use the A to I function. Okay, so now the working principle. Let's see, this is a client-side working principle that we need to first define the package structure. We need to read the file. So in the dividing them into sections, like suppose we have mentioned that the buffer size or the segment size will be 10 bytes of data. So in segments, we will need to divide that. We will create the connection and establish to the server. We will open a log file if that is not available. If there is a log file, that means there will be a partial transfer. All it is there may be some data sent, and that can be new file. So if there is a empty, then it will create an empty log file if not available. Otherwise, it will not delete the file automatically. Then the stop and wait protocol will be initialized to send the file. It will add the message data, sequence number, and whatever else needed. They send the message and store into the log file. Then if the acknowledgement received, add in the log file also. Then every time it is maintaining the log file, you need to maintain. So the more the log file we will maintain, the more accuracy we will get in the stop and wait protocol. And if it's a fault that the connection is broken, then it will resend the log file. Sorry, not log file. It will resend the frame or segment, whatever we say. Here we are actually transferring from the transport layer TCP communication. So that's why we are mentioning that is a segment, but we can say any other thing conventionally. So in the server side, working principle is we are mentioning creating the packet structure. Same type, because when we are client is sending actually the packet structure at the first moment when it is beginning the connection. So the packet structure should be same at the both side. Client, what is client maintaining, it should be maintained by the server also. Now it is establishing the connection, creating the log file, and the hello.
Yes, yes. Please continue. Please continue.
Okay. So now the stop and wait protocol, here we are actually it is a loop, because server will wait for the data. So it is in a loop. It will, when it will receive the message, it will process that, and again it will wait for the another data. So it will run in a loop file. So this is the packet structure. So here you can see the first we have this sequence number, we have the acknowledgement, we have already set this one. By that we in the default we didn't receive any acknowledgement. So acknowledgement is 0, sequence number is 1, and it is a contain the acknowledgement number. So there are different segments, and finally the raw data. In another way, it comes to the transport layer. So TCP header will be added. From it will go to the network layer. IP header will be added, and finally in the data link layer. So Ethernet header will be added. So like this way, this data is automatically will be added. We need to just add this data. It will be automatically added by the when we will create this function. We will use the socket connection. It will be automatically added, this type of data. We just need to maintain this data, because here the sequence number or acknowledgement, it is for our file. When we are suppose we are using the TCP, we are sending in data, and it will automatically wait for a receive response. So that acknowledgement, that time, it will be automatically maintained by the program. It is in default. But here actually we need to see that we need to send that file, the specific file. So for that we have to explicitly send this sequence number. This sequence number is also sent for that for the connection, for every connection we are when we are sending using the TCP. But we also explicitly tell for our file that what is the sequence number of this file. So this is the packet structure. what we are sending, we are first sending the message ID. Message ID means it is a can be the file name or yes, it is a file ID or something like that. Now number of segments we will send. So actually it will be sent the first time to the server, that how many segments I will send to you. Suppose I have given that there will be 100 bytes each segment. So if there is 1,000 bytes of file, that means the number of segments will be 1,000 by 100 equal to 10 segments. So 10 segments I will send. What is the file size? That is 1,000 bytes. Transfer started at, this is the here you can see this is the time function, means the time type of data. Transfer started at when the transfer started at the client side.
Hello. Just wait. Okay, wait. He'll join within 1 minute.
Sir, am I audible?
Yes, yes.
Sir, is it visible?
Yes, yes.
So here is the message ID or the file ID, the number of segments we will send, the file size, the transfer started at, it will be logged by the client and also by the server. Transfer completed at, it is actually for specific file what we are sending to the server. Struct current status. So this one is one time will be maintained, means for the starting time it will be logged and in the ending time it will be also logged. But this current state will be logged at when we are sending byte by byte, means time elapsed means that how many time means we are sending the data, so how much time already elapsed. Okay, so this is the time elapsed part, means that time completed means current time minus the time started at, current time and minus the time start. So it will be updated at each time when we are sending the file, the segment number what we are sending to the server, and the transfer completed flag, that whether the transfer already completed or not. Because suppose we are starting the program, a new program, and it will read the log file. When it will read the log file, it should know that whether the transfer, the previous transfer already completed or not. If it is not completed, that means I need to send the rest of the file, rest of the data. So for the rest of the data, the zero will be there because zero not completed, the previous transfer not completed. And if it is one, that means already the file transfer completed. So, okay, so there can be two things. When to send the packet structure? There can be two cases. One is for the concurrent server and one is for the sequential server. For the concurrent server, we are actually handling multiple files at the same instance. The concurrent and the parallel, these are the two different things. Parallel means we are receiving two files simultaneously, but actually concurrent means we are maintaining two types of files one by one. So there can be concurrent server and sequence server is sequentially that file. First one I have received this file totally, and then again a new file transfer should be begin. So here I have implemented this one sequential server, but for the concurrent server we need to send this packet structure every time, because suppose we send the file one file. Suppose there is a two files, file A and file B. First, we have sent the data frame or the segment for file A. The file ID will be file A and the data will be there. So when we are sending this, server will be able to know that it is from the file A, and again we are sending for the file B. So server also should know that for what segment it is, for file A or the file B, because it's a concurrent server. It is handling two files simultaneously. But for the sequential server, when a transfer started for a file A, that means until and unless the server the transfer completed for the file A, file B will not be transferred. So we don't need to send this packet structure every time in the communication. We just need to send the first time. So here I implemented the sequential server. Concurrent server, we just have to send this multiple times. That's this difference. So here the client server architecture. First, client will start the connection establishment. If it is failed, if it is not communicated with the server, then it will exit from the program. If it is not failed, then it will read the file and do partition in segments. So as I already told that it is 1,000 bytes of file and each segment is of 10 bytes, then there will be 100 partitions. 1000 by 10 equals to 100 partitions. And here you can see I am sending this packet structure for one time, for first. I am not sending at every time here. Then it is reading the segment byte by byte from the file and it is sending to the server. But I am sending the packet structure at once. When you are sending the packet structure, it is received by the server and the server initialize in the secondary storage. Means actually it is also maintaining the log file that what I am receiving. And finally, it is appending to the file. When you are receiving segment by segment, it is appending to the file. And finally, it closes. When the client requested to close the connection, means the total file transferred. Here you can see that suppose client sending the file. There is a 100 bytes of file. 100 bytes already sent. And client didn't send a close connection request that server you can close the connection. I have already sent the whole data. But then also server can close the connection to that client because server already know how many segments I will send here. Here I have already sent the number of segments. So server also know that how much bytes I will get and how many segments I should receive. So server can also tell the client that I didn't receive this byte. It can be also configured like this way. So this is a proposed architecture, and finally the implementation part. So implementation part, we should use some header files, some other from the standard header files. So these are the socket libraries we need to use. These are some standard libraries like stdio.h for the input output standard library and the string header for string handling, and it is a time.h for the time handling. So this is the packet structure I mentioned. Here you can see the buffer size. If this is a buffer size, is actually the segment size, you can say. So here I mentioned that there will be 10 bytes of buffer. Means I will send 10 bytes of data at once to the server. Again, I will read the 10 bytes and again send to the server. Means I am not sending to the server byte by byte. I am reading the file byte by byte, one byte at a time, but I am sending to the server at once 10 bytes. So server is running on the 5000 port. Here is the server port I mentioned and told to the client. And this is a transfer info. This is the packet structure actually. File already I told this one. Okay, so I am taking the input from the command line that what's the file name? It is in the client side. What will be the file name? So if I didn't give any file name, that it will just remove. Means it will just exist from the program. Here the argc is the argument counter and this is the argument array. So argument counter will be always 1 because I am specifying the file name, the specific file name, the program file name actually, and another file name will be for the file name, the file I am sending to the data through the server. So if the argc equals to 1, that means just I am running the program, the file name of the program. And if it is argc equals to 2, that means there is a program name also with the file name that file I want to send to the server. Now this is the client side and the server side. Client side program is for the connection establishment to the server, and server is binding and listening from the clients. So here the log file. This is a log file program I already told. So this access function is actually checking that whether the log file present in the client or server side. So here is the log client, means it is a client side, and there will be log server which will be maintained by the server, and that will be in the server side. So here you can see also that the log client file is opened in the read binary mode, because the t info, this one, you can see this one, t info, it is actually the structured variable. I am specified this is structure struct type. It is defined in the type what is for this variable name, struct transfer info, and this is the variable name actually. Sorry, this one is the variable name. Struct transfer info is the actually the structure name. This is the variable name, and CS is actually the variable name for this nested structure current state. Means if I need to access this variable time elapsed, then I need to first call this variable tinfo dot cs for I need to access this variable dot time elapsed. Means it is a nested manner. It is because I have done this hierarchical manner, because this one will be only updated by when we are sending the data, and this one will be updated at once only. So that's the difference only, but you can also define it in the outside. There will be no problem. Okay, so here I've already told this one that f read is actually the for the reading the structure. Here you can see that I am checking that whether the log file is present or not. If it is present, then the client will read the log file. So to read the log file, it is already there written the structured data. It is not a text or string data, it's a structured data. So to write the structured data, we need to also write in a write binary mode. So if I have written the write binary mode, then I have to also use the read binary here. So here I have specified read binary, and then I am here specified the t info is the structure variable reference, size of t info, what is the structure size, sorry, the variable size, how many structure I am reading, just one, and the pointer where I am opening the file, pointer to the file, and finally we will close that after reading. Now synchronizing with the server. So here you can see for the first line I am checking whether the file name, what we are giving from the command line, there's a argv1. I already told that the argv0 is the program name, because already program name is present, and argv1 is the file name what we are sending. So argv1 is equal to the tinfo message id, that is the file id. Here we read the log, and after that we will check that the two IDs are same or not. If it is same, that means the same transfer will be begin. That is the previous transfer actually we are seeing. If it is not same, that will be a new. Means in the else condition it will go to the new file. That will be a new transfer. So if that is the same file, then I have to also check that whether the transfer completed or not. If I see that the transfer completed, then it will be printed the file totally transferred. And finally, the client will send to the server that you can close the connection. I will not sending anything. I will not be sending anything. And if the transfer is completed, then this else part will be done. The file partially transferred. That means. So file transfer is transferred. So I have to also send to the means here actually we are sending again that what message ID, what file ID I am sending here. So we are sent the first data. Then we have just here we have printed the kind partition number, packet number. Here you can see this is I to A. It is not A to I. So why it is I to A? Because at the beginning of A to I, it is converting string to integer, and it is actually converting integer to string, because the tinfo file that is I am reading using this structure, it is in the integer format. Here you can see the file. Int is number of segments, or it is an integer. So integer cannot be sent to the server. Sorry, yes, to the server using the send socket function. We need to convert that into the string. So that's why we are converting the integer to the string using this function. And finally, we are sending here. You can see the send function. We are sending the buffer data. That is from where we will send the data. If there is 1,000 bytes of file, I already send the 100 bytes, so it will send the 100. That from after the 100, I will send the data. Send, and again, it is a common thing that TCP will wait for the response from the server, so it will respond. And if it is receive that received data, here you can see I am checking the saved offset. It will be actually sent from the server that yes, I am got the offset. You can send me now. So when it will get the saved offset data, that means it's okay. And if it is not received any response from the server, that means there is a problem. So server offset not received, server offset not received, and finally it will close the connection. So this one is the folder when the file ID already present in the log file, the same file name we are sending. But if there is a new file, for the new file, you can see here, I am first initializing the transfer started at variable. T-info transfer started at variable with the current time. Using this function, I am assigning that time. After that, we are copying that T-info message ID from the argument. Whatever we are sending from the command line, we are copying this argument to this message ID. Then we are assigning the transfer completed at 0. That is means that right now the transfer not completed. Packet number is 0, or you can set it as a segment number, whatever you want to say. You want as a conventional this one. Number of packets we will send. It's all thing will be 0 right now because it is initializing first. Then this configuration, this is the actual packet structure. This is actually packet structure we are sending one time. Here I already told in the proposed architecture that we will just send the one time this packet structure. So here we are sending the configuration to the server, and server will give a reply that yes, I saved the configuration. If the server configuration not saved, then it will again close the connection. Yes, sir?
Deepnaran, if the connection is somehow closed, then in that case it will send once again, or
no, sir. That time it will be closed, and when I will again start the program, it will again try.
I'm asking you the resuming part. It will send once again, or it will not send?
So server configuration will be sent one time, sir.
Okay.
One times.
Mm-hmm.
Then actually it sent the server configuration. Now it will send the offset. So offset is already 0. Now there will be a question that why we are sending the offset, because we need to maintain it a sequential manner, that first one what we will send, because server is know that if there is a new file, I will first get the configuration part, then I will get the offset part, like this way. So we are just sending the offset that it is 0. Already we have assigned the 0 from the beginning. I am sending to you. Then it says that offset I received. Then okay. Then it will again continue this client part. Now the file reading parts is actually here. Here you can see the partitions calculated to read the total file. So what are the partitions? Means the partition can be changed according to your program. Like here you can see that I am first reading the file using the read binary mode. I am going to the end of the file. I am using this ftail to know where is the pointer position right now. So I will get the file size. Again, now here you can see I am actually setting the pointer to the offset part. For the new file, it will be 0. That means it will be the beginning of the file. And for the offset means if it is not a new file, it's a partial transfer. That means that time it will be after the 100 bytes or after the 1000 bytes. Up to much I have read. I have sent to the server. So that's why I am using the fseek here, and here the offset variable. Now I am assigning the file size here. Here, this one is actually the segment size. Here you can see I am sending the buffer size where it was 10 bytes. So 10 bytes of array I am creating here, cat type array. Because cat type array, 10 bytes means each container will contain 1 byte of data. Now the partitions is, you can see f size by size of char. So size of char is 1 byte. So suppose f size means there is 1000 bytes of data, 1000 bytes of file, and size of char is 1. So that means partitions will be 1000. 1000 by 1 equals to 1000. So partitions is actually saying that how many times I need to read the file. How many times I need to read the file. So 1000 bytes of data, that means 1000 times I need to read. That's the thing. Now here you can see that in the function the for loop. So I equals to 0, j equals to 0, I less than partition. So why I less than partition? Because the partition is the total number of bytes. So I need to just less than, do the less than, because it will be, if it is in less than equal to, then it will go to the end of the file. So before that I need to stop. So less than here, I equals to 0 and j equals to 0, because I equals to 0 is to read the file. So I need to first start from the starting. That's why it is 0. And j is actually used to maintain the buffer size. Means here you can see first is for loop will be run. This j equals to buffer size, it will not be the condition will not be satisfied because j equals to 0 but buffer size equals to 10. I have already specified there 10. So this condition will not be specified. Here it will read 1 byte of data and it will store where the j is 0. Means 0 location of the temp array, it will be stored 1 byte of data. Then the segment number I have initialized, then again it will run. I am telling why it is later. Again it will run, again j equals to 1, then this condition will be satisfied, then it is storing the second point, second byte to the 1th location. Like this way, when the 10 times it will run, that means that size, this array, this buffer or segment is totally filled with the 10 bytes of data from the file. So when the 10 bytes of data read, j already 10 and buffer size equals to 10, that means this condition will be satisfied. When the condition is satisfied, then it's the time to transfer the data to the server. So send the, here you can see send socket descriptor, then temp means the buffer data, and the buffer size I need to mention that is the 10 bytes of data, and we are sending the data. Now we in default we are also waiting for the receipt from the response from the server. If server sending that yes received, that means this segment received. I am incrementing the segment. Here you can see the segment number I have already mentioned. This segment number and this one is different. You can see there. This is the current status segment, tinfo.cs, current state. The segment number means where is now I am. That is the current state segment number. But this one is the how many segments I sent. How many segments? Means 1000 bytes and 10 bytes each data. That means there will be 100 segments I will send. So this is one segment I sent. Now there are rest 99 segments. So it's saved to the log file, and again will the connection will be means this loop will run. So here you can see the j. I reset the j, means the I need to also go to the first position of the segment size, the segment of the temporary buffer. This temp variable is of 10 bytes of data. Means I already read the 10 fill the 10 bytes. I send. Now I again position to the first point. So when I position to the first, that means the buffer will be overwritten now. Okay, the buffer will be overwritten. So, but here you need to I need to mention that every this pointer, what it does, when you will run this function, the file pointer, where from it is started, it is started from the beginning of the file. So when I will run this function once, automatically the file pointer will be incremented by 1. You don't need to increment explicitly this one. Here I am incrementing this j, where it is, yes, this j++ to store the data, but it is not the file pointer where I am incrementing. Whenever you are running this file fread function, automatically file pointer will be incremented. So 10 bytes of data I have read, I stored the into the temp buffer, I sent the buffer to the server, and I reset the buffer. Means I already set the pointer of the buffer to 0th location. But I can run this data. There is no problem because this file pointer is maintained by the program automatically. So when I will again run this function, it will read the 11th byte of data. 11th byte, then it will go to the 12th byte, but actually j is again from starting from 0. So again it will go to the 10 and the condition will be satisfied. That time it will send the 20th byte of data because 10 to 20 now stored to the temporary variable. First it will store the 0 to 9, then it will store the 10 to 19 like this way. The temporary variable will be stored and it will send to the server. Here I have just given the sleep function once to see the communication. Otherwise it is not needed. Sleep function. This sleep function will give us a delay in the communication. And right now this one, I plus temp segment number, usually 5 say. So what is it? It is actually, suppose suppose there is a partial transfer. So partial transfer means consider there is 1000 bytes of data and I have already sent 100 bytes of data. So rest is 900 bytes I will send. Now when I will run this function, then again this program again, it is starting from the 0 and it will go up to the partition size. Partition size is how? That is 1000 because 1000 by 1 is 1000. So I am reading 1000 times this using this function, but actually I need only 900. I need just 900 bytes. So that's why I am here specifying that the temporary segment number is already initialized with the this number, this current packet number, that where I have to do the offset. So just the temporary segment number, if it is added with this I, the partition size, when it will be equal to the F size, file size, that means I already read the data. Because just 900 byte will be 900 times the loop will run, and temp segment number already initialized with 100 because 100 bytes I already sent. I logged that data. 900 plus 100 equals to 1000. So when it will see that already 1000 bytes sent, it will break the connection. I don't need to run the 1000 times this one. So this is for the partial transfer. Next, here you can see, suppose I have a 30 bytes of data, and 30 bytes is actually the 10 bytes of segment. This is the 10 bytes, these are 10 bytes, and these are 10 bytes, 3 rows. Now, 3 segments or 3 rows. Now I have 27 bytes of data. So first segment will be totally filled, 1 to 10. Second segment will be also totally filled. But there is again there is a 10. The segment size is same, that 10 bytes of data. But in the last segment, there will be only 7 byte. Okay, but there will not be covered the rest 3 bytes of data. So what is the problem here? If it is not completed, the 3 bytes of data, that time this J will be assigned with 7 already. 7, not it will not be 10. So if it is not 10, that means it will not be equal to the buffer size. So if it is not equal to the buffer size, that means this function will not run. That means I send this segment first, I send this segment again in the second time, but in the third time, the client program will not send this last segment because this function didn't execute that time, will not execute. So for that, I need to explicitly say that whether the J equals not equals to 0. Because if J equals to 0, that means this function run at the last time. If it is run, that means the last byte of data sent to the server. But if it is not run, that means if it is J greater than 1, that means there is some rest byte of data which is in the segment available. So I need to also send that data. So finally, I am again once running the send program, the socket program. It will send the rest segment of data. When it will receive, it will increment the data and it will again save. That's the same thing. The rest part will be explicitly sent once time. We need to check that there is any rest data is present in the segment or not. Okay, so now this is the server part. In the server side, I am here. You can see. Show you. Yeah, here it is sent from the server, from the client side, that send socket close sock, and we are just specifying that how much length it is using the str length, because I already told them using the send function, the socket send function, you can only send the string. So that's why I am here using the string length. String length, we are getting the data size, and we are sending to the server. So this is actually accepted by this function. That whether the received data is equal to the close sock or not. If it is close sock, means client is requesting to close the socket with the client. So it will close the socket. Next one, here I already told that there should be a sequence maintained. Like first I will receive the configuration, then I will receive the offset, like this way. That's why there is a transfer sequence I am maintaining. If the transfer sequence equals to 1, that means I will receive the configuration. If it is 2, that means I will receive the offset part. So here you can see when the transfer sequence is 1, that means client send the file ID or the message, the configuration details. It will get the configuration. It will send to the server, to the client, that yes, I saved the data, and it will automatically increment the transfer sequence 2, means it is ready to receive the offset part. So, okay, let's show you this part first. So here it is already for else if the transfer sequence is to 2. That means it is now when again client will send some data, this function, this code block will run because it is already implemented there. So when it will receive the offset part, it will convert to that and again save the data. Here, if it is a packet number equal to 0, that means I already told that whether it is a new file or it is a partial transfer, already sent some data, the packet number will be sent. So if it is a packet number equals 0, that means it will file reset. Means actually it is a new file, or I am sending the file again from the beginning, like this way, and it will set the transfer sequence equals to 0. Like this way, actually I am maintaining to the server that when what type of data I will receive. And another thing is that here, if the transfer completed string is sent from the client, then it will match that whether the transfer completed means client saying that transfer completed from my side, then it will first initialize this transfer completed part, that when the what is the time right now transfer completed at, it will assign this value to the time elapsed, that is actually is the time difference will be calculated here, the transfer completed minus the transfer started. It will be calculated, assigned, and finally the log file will be set. Means the log file will be saved at the server side also. Now this is the else part. Suppose the transfer sequence, here the transfer sequence was 0. There is one condition for this code block. For 2 there is a code block, but for 0 there is no code block. That's why this else part will run. This else part means this will receive the segment. This will actually, this part or the transfer sequence one, this part will run for once when we are sending the data, but this part actually will run to receive the segments when we are sending at the last time. So how many segments we will send, that many times this program will run, this function code block will run. So when it will receive the data, it will was here I am opening the file at the server side is the append binary mode. I am appending the data. Okay, I am appending the data. There may be a question, suppose there is a new file, then what will happen? For that, you can see here, I am seeking the file pointer. I am again setting the file pointer. So that's why if there is a file already sent or not sent, I am setting the file pointer explicitly. So when I will append, I know that from where it is appending the data. Now when it will receive the data, it will loop, and byte by byte it will write the data. When I am reading the data, I am reading byte by byte, and when I am writing the data, I am also writing byte by byte. Here you can see the size of CAD. 1 byte I am writing one at a time, and to the from the received data. This is the data. This is the temporary buffer at the server side. We are writing the data from this buffer to this file pointer where I have opened. I open the file. I close the file like this way. So thank you. Is there any query? Sir, will I run the program?
Is there any query? No.
Okay, sir.
So please run your code.
Okay, sir. So here you can see we have different files, input docs, MP3 file, this is a doc file, this is a MP3 file. So, and this is a text file also. Now, and also an image. And in the server side, there will be also a log file. So we need to first delete the log file, else it will be a parser transfer or something else. So just deleting the log file. To compile the program, we need to run gcc space.
You can create log file, different log file for different files.
Yes, sir. Okay.
In that
Okay.
case, I must.
Yes. So the two programs compiled. Now let's start the programs. So first, we need to start the server. So server listening at the 5000 port. And now let's begin the client. TCP client. And now we can send any type of file. Let's show you. So here I have specified the buffer size. The segment size is 400 of bytes. Okay, so once let's do it at 10 bytes of data, so it will be more understandable. TCP client. I'm sending this doc file input.docs. Okay, it's already present in the server side. Okay, now at the server side there is no file present. At the client side, from the client side, I'm sending the file. So here I have given so this is the ARGB 0 and this is the ARGB 1. So two arguments are there. Let's send, and here you can see that this is there are 10 points, means that at each time 10 bytes of data it's receiving from the client. So client is also getting the response from the server that it's received the segment.
You can close the connection.
Okay, sir, I'm showing that. Here it's already sent the data. Now let's see by closing. Inside also a log file created. So when I will again specify the log file, okay, I need to bring the server. Same file when I am specifying, it is still that file totally transferred. And you can see here the server connection closed, because when the file totally transferred, the client sending the close connection request to the server also. Okay, so let's delete the file. Okay, once I'm showing one thing, that if I give a new file, and the file if I give, then there will be no problem, because I am checking there is a same data, same file ID I am sending or not. So I am sending a new data, again it is sending. Okay, so let's increase the byte size. Okay, so it's sent. Here is a client in the server side, it received the data. Yeah, it is a program, and it's interrupt. Okay. So now I will block the connection, break the connection a bit. Oh, totally transfer. Sorry, this intake log file into delete server side. Okay.
It is better create a different log file for different files. Then without
Yes,
deleting the
yes,
log file, your program will execute. No?
yes. Yes, I break the connection here. Now I can reinitialize the server, started the server, and start the program again. Yeah, should I receive the REST part? Let's see. It's the server side. Okay.
What happened?
Yes, sir, something problem is there, sir. Just a minute. I'm again starting.
First you compile the code once again, then you'll start.
Yes.
You have modified some lines.
Yes, yes. Okay.
Compile the code.
So actually, I think. Okay, okay, I just modified this. 50 words data. Words. Okay. Yes, it's transferred.
Hmm.
Yes.
May the resume part is what?
Say resume wherever I have given resume.
Hmm.
Okay. Say here. Here, sir, I have broken the connection.
Mm-hmm.
Broken the connection and again it resume from there.
Okay.
Again.
So is there any
Sir,
question?
actually,
Dibran, please continue.
is uh, so what will I show next?
No, it's okay. It's okay.
Uh,
Any other things you want to explain? Okay. So all the students, I have given small
Yeah.
assignment to you. So you have to complete that assignment within the deadlines. Okay. So please check your classroom. So I'll show you. I'll show you your classroom once again. Yes. So I've given one task, that stop on it protocol with resume part. You have to complete this task. Okay. And I also given another task, chat application program. There's a full duplex communications. uh, Full duplex chat application program using thread. So you have to complete these two tasks as early as possible. Okay. So I've given the deadlines. Okay. Thank you. Thank you, Dibnaran. Excellent presentation.
Yes. Thank you, sir.
Hmm.
Thank you, sir.
Okay. Is there any question?
Sir, can you explain the full duplex chat application once?
It looks like a when you are sending a message in WhatsApp. What will be happen when you are sending the message? The same time receiver can send the message to the clients. So
Okay,
both
okay.
can be sending and receiving. It is possible the same time. When you are writing
Okay,
something, it is possible that you will receive the message. So there should be a two child process. No? One is sending, another one is waiting for the receiving.
okay,
Am I
okay,
right,
sir. Yes,
Niket?
sir. Yes, sir. Yes, sir. I understood. Okay, sir.
जो
Thank
हम
you, sir.
लोगों ने नॉर्मली करते हैं, जो फेसबुक में करते हो, जो भी नॉर्मल चैट एप्लीकेशन प्रोग्राम, when you are sending, you are getting message. So both should be active at the same time. So and you have
Yes,
to
yes.
create a thread. Without thread, it is not possible.
Yes, sir. Okay, sir.
Okay.
I understood, sir.
So Deepnaran Aniket, please complete the second task, the chat application programs. Okay.
Yes, sir.
Yes, sir.
Okay. Okay. Thank you to all. Please
Thank you,
complete your
sir.
task as early as possible. Okay.
Thank you, sir.
Okay, Baba.